Assalamualaikum. Hello, welcome to EBB 212. In this lecture, we will learn on chemical synthesis of ceramic powders, focusing on liquid phase or wet chemical synthesis, which will cover on precipitation, sol gel, hydrothermal, nanoemulsion, and combustion. But first, we need to know the advantages of LPS over SSR. In LPS, we are allowed to fabricate directly coating and fibers without powder intermediates. For instance, if you have a metal sheet that you want to coat with ceramic material, so you can prepare a ceramic coating solution and directly dip the metal sheet or spray the coating solution on the metal sheet, and you'll get a coated metal sheet directly. Okay, LPS could also improve chemical homogeneity on molecular level, particularly when performance powders dependent on the composition of dopants. Okay, so in this case, if you want to formulate the composition of the powder, okay, so you can introduce other trace elements into the powder to enhance the performance of the powder, and this is what we call dopant. And this can be done through LPS. LPS could also improve mechanical properties for structural ceramics because we can produce fine and control particle size and shape of the particles. Okay, by having these powders, we could also reduce diffusion distance on calcination. Calcination is a typical heat treatment performed on powders to complete the reaction. Regardless of liquid phase synthesis that you intend to do, the first stage is to prepare a solution. So the question is, do we disperse solute into solvent or solvent into solute? So you can do a quick experiment by preparing a coffee. So you have coffee powder and hot water. You can pour hot water into coffee powder or coffee powder into hot water and see the difference in dispersion. The answer here is to disperse solute into solvent to get a good uniform solution. Then you have to consider what is the best solvent to use to dissolve solute. So you have to check the solubility of the solute used, whether they disperse well in alcohol-based or in water-based solvent. For LPS, we normally use solute that is based on nitrate, carbonate, phosphate, or hydroxyl, and we try to avoid using oxide-based solute because oxide-based is difficult to dissolve in any solvent, and they are normally used for SSR instead of LPS. So for LPS, if you have a choice, go for nitrate-based solute. For what the solvent, we can decide whether to use water-based or alcohol-based depend on the synthesis method that we want to use. And finally, you have to choose the right choice of water source. Okay, so because our aim is to produce high purity powder for advanced ceramic applications, so we have to use distilled water or deionized water. We cannot use tap water as tap water contains a lot of foreign materials such as organic compounds. So we have distilled water or deionized water. Distilled water is better than tap water but might still contain some organic compounds because distilled water is processed through thermal method or distillation where the water is transferred from vapor phase and subsequently to condensation and you get distilled water. While for deionized water, it is processed through reverse osmosis based on double passage of raw material through semi-permeable membrane under pressure. So that's why deionized water is highly pure. So if you have a choice between deionized water and distilled water, go for deionized water. Okay, so we will learn on synthesis method on the next lecture.